Okay, so here's where we're at. Sometimes you get polynomials that look complicated, that you don't know what to do. It's sometimes easier to see if you could do some sort of substitution. So if something looks complicated but you see something there, maybe. To better work at it, it's sometimes easier to make it into a simpler form by substituting in for the complicated looking piece for something simpler. So for example, in this problem here, I've got this 2a minus 1 squared and 2a minus 1, and so what I'm thinking is it looks like a trinomial in this variable here. So I'm thinking, what if I just replace that with x? So off to the side, so if I just say, well, let x equal 2a minus 1. And so if then I substitute in for x, I get 10x squared minus 19x minus 15. And now I know what to do with this. Or it's a lot easier to see what I can do with this. Now I can use the AC method, right? See if it's factorable. So now what I can do is I can use the AC method and I get negative 150. So I want two factors of 150, negative 150, that will give me negative 19. So, and the larger factor is negative. Okay? So what might work? Well, let's see here. Let's see. 6 and 25. So 6 and negative 25. That will do it. And so now I can decompose this. So I get 10 times x squared minus 25x plus 6x minus 15. And so now I'm going to group these and group these. So now I get what? I get 5x times 2x minus 5. And then over here I get plus 3 times 2x minus 5. And now I'm going to factor again, and I get 2x minus 5 times 5x plus 3. Now I'm not done, because now I got to put back in what x is, 2a minus 1. So now this is going to be 2 times 2a minus 1 minus 5 times 5 times 2a minus 1 plus 3. So now I'm going to simplify this. Okay, so now how is this going to simplify? Well, let's go up here, see what we get. Well, this is going to simplify to 4a minus 2. So let's do this down here. So 4a minus 2 minus 5. And this is going to turn into what? This is going to turn into 10a minus 5 plus 3. Okay, so now guess what? Now I can simplify this, and what do I get? I get 4a minus 7 and 10a minus 2. Is that right? Yes. And we're not done. I can factor out a 2 here. So this will be 2 times 4a minus 7 times 5a minus 1. Bam! So what looked like was really complicated turned out to be nice and easy. Again, a little bit of work, but a lot easier than trying to do it without the substitution. I'll tell you that, because you'd have to expand this one out, then you'd have to simplify this one, add like terms. I wouldn't want to deal with that. Okay, let's do another one. Okay, so let's do this one. So now this one has the same sort of idea. So now it's got the same thing. Got a complicated thing here. It's cubed. This is a perfect cube right here. So what do I do? Again, substitute in for x. Make x equal 2a minus 1. So now it's going to be what? It's going to be x cubed plus 2 cubed. Now, I know my pattern, right? So it's going to be what? It's going to be x plus 2 times x squared minus 2x plus 4. Now I just have to put in what x is. So it's going to be 2a minus 1. So it's going to be 2a minus 1 plus 2. And then this is going to be 2a minus 1 squared minus 2 times 2a minus 1 plus 4. Okay, so now we're going to have to simplify. So this is going to be what? This is going to be 2a plus 1. And what happens here? Well, this is going to be what? This is going to be 4a squared, right? Minus 4a plus 1. And this is going to be minus 4a plus 2 plus 4. Again, all I did was FOIL this out to get that. And then I just distributed the negative 2 to get this. And then, of course, plus 4. So now, what do I get? I get 2a plus 1 times, well, what do we get here? We get 4a squared minus 8a plus 7. Let me make sure that that's correct. That is correct. All right, we're done. That's it. So let's do another one. One more. That was part B. Let's do part C. So the last one is this. Okay, so now this one, not bad looking. So in this case here, I've got z to the 4th and z squared. So this one is double this one. So it looks like it's what we call quadratic in form. All of these are quadratic in form. Okay? Well, not all of them. The last one wasn't. Okay? A was, right? So is this one. So we want to get it into a quadratic, a trinomial, right? So I'm going to make x equal to z squared. So now this will become what? 6x squared minus 13x minus 5. So all I did was substitute in here. So this is what? Z to the fourth is the same as z squared squared, right? So then I just put in here x, so I get x squared, okay? That's all I did. And so now I can use the AC method. So I get negative 30, so what two factors of negative 30 will give me negative 13? Yes, there are. So it will be, let me think. Oh, yes. It'll be 2 and negative 15. 2 and negative 15 will work. So now I'm going to decompose. So this will be negative 15x plus 2x minus 5. And of course, I'm going to group them. And then the greatest common factor here is 3x. So I'm going to end up with a 2x minus 3, or excuse me, 5. And then here I'm going to end up with 2x minus 5. So let's just put a little 1 out here. Okay, so we can see it better. And so now I've got a common factor, and my final answer is going to be, well, not my final answer, but 2x minus 5 times 3x plus 1. And now I'm going to stick the z squared back in. So now, let me go up here. So now it's going to be 2, what is x? Z squared. So it's going to be 2z squared minus 5 times 3z squared plus 1. And we're done. That's it. Have a great night.